So there's different categories of regressions. The first category is, here are all the points, just make it happen, okay? Just make it happen. We're going to start with that, but then we're going to transition over to, you have to come up with the points. You have to use some of the properties of that situation to figure out more points. We did that last year already, and that was in preparation for this year. So if you wouldn't mind entering these points again. I know some of you have already done this, but I just want to make sure if there's anything that I need to clarify, this is your chance to make sure you get this, okay? So to enter this into L1 and L2, we go stat edit, you clear everything that's in there, and then just type that in. So I encourage you to do the same. Make sure the L1 and L2 are the same, have the same amount of data points. I've been told that they will always tell you which regression to perform. That's what I've been told, but I want to prepare you in the event that they don't tell you which regression needs to be performed. You need to be able to like justify, okay? So what I do is I go to y equals, let's clear any equation that is in y1. Make sure plot 1 is turned on. Okay, it has to be highlighted. It's basically a scatter plot. That's what plot 1 is. Like, you want to see a scatter plot of what you have in L1 and L2. Then I go zoom, and I press zoom statistics. And it actually, 99% of the time, this is going to help you determine, like, what is this? Is it quadratic? Is it cubic? Is it a linear? It's definitely not a linear. I hope you didn't even consider that one. It could be a quadratic if all you had was that, right? It's like, oh, there's a quadratic. But because you have the second turn here, this must be a cubic regression. Okay, so in this case, we'll perform a cubic regression. So let's go ahead and do that. We go stat, calculate. Oops, what did I do there? Calculate cubic regression. We feed it L1. We feed it L2. We tell it where to store the equation. We go alpha, because most of the time I'll ask you something else about that equation. So you might as well put it into y1 so it's stored. Okay, and then you hit enter. Oh, I just noticed a problem here. You probably didn't catch that on the video. Maybe you did. Do you notice this here? E to the -4, which means this is incorrect. That means that the decimal has to shift how many places to the left? We can't have 0 for A. Then it's not a cubic. We have to shift it 4 decimal places to the left. Okay? So that's a good, see, that's one of the reasons. Maybe I did this on purpose, you'll never know. -8.491, and that keeps going. E to the -4, okay? That means we have to shift it over 4 places. So I'm going to copy down the first couple, and I'm just going to take the decimal, shift it over 1, 2, 3, 4 spots. That's where the decimal goes. And everything else, this doesn't really happen on an exam. I'm just letting you know, and on a test. But I think it's good to know how to deal with this situation. So you just fill in the values you've created by shifting. You fill that in with zeros. Okay. All right. So that is what we put in here. It's -0.0008 x cubed. Good thing we caught that. Okay, so if that ever happens, this is kind of like an aside. It basically has to deal with that leading coefficient, which cannot be 0 if you want to have a cubic regression. It cannot be, okay? So that's that. Once you've copied down the equation and you've stated what it is, hit graph. And if you did this right, it should go through all the points. Okay? He's getting sick these days, eh? I'm fighting something for sure. Anyway, so this is what it's supposed to look like. I would say you want to increase your x max in this case to make sure this x-intercept is included. So we're going to go ahead and do that. X max, I change it to 60. I hit graph again. And that is a good graph right there. For A, what regression would best fit the data? We can just say the scatter plot shows 2 turns. Indicating a cubic regression. Okay, so that's kind of my justification for choosing cubic as the 2 turns. Okay, if it only had 1 turn, then I would call this a quadratic situation. If it had no turns whatsoever and it just seems to be going in a straight line and it's linear. Okay. What is the highest vertical displacement? So I guess we should make sure we understand what's happening here. Based on what you've been given, the x variable represents horizontal position, and the y variable is the vertical displacement up and down. Okay? So what's the highest vertical displacement? It's asking for the y value. Y value, right? That's what it's asking for. The highest y value here. And where would that be found? It could be right here at the y-intercept, but it could also be found at the highest point here. Okay, so I'm gonna investigate. I'm gonna find this max here, second trace max. I'm gonna hit enter and enter again. So maybe I'll just do a little sketch here on the side where I just see this, it goes up and then back down. This point right here is 3373, 5.05. And what is the y-intercept here? Do I need the calculator for that one? Technically, it is 5, right? By the equation, this is 0, 5. If you didn't know that, then you would go and investigate. So not by much, but it's slightly, this one is slightly higher, a greater vertical displacement. So the answer is 5.05. I will go second, trace, max, and it's 33.73, 5.05. So 5.05 centimeters is the maximum vertical displacement. I guess I didn't introduce this word problem properly. We didn't read it. But it's basically there's a computer-controlled cutter with a matching arm, right? So you gotta kind of have to imagine there's like a piece of wood, like a flat piece of wood lying down on this table, and there's like a machine that cuts it, right? So there's horizontal movement of that arm. Arm moves this way and up and down, vertical. That's what's happening here. And so in this case, it's 5.05 is the greatest vertical displacement. What is the zero of the curve? what does it represent in words? Anybody remember what the zeros are from last year? Summer probably didn't help, right? It's the x-intercepts or the roots. They also mean the same thing. Or the solutions. Okay? Emphasis on x-intercepts. Just remember that the zeros are the x-intercepts. And in this case, you would just say where the arm makes contact with the edge of the board. So if this is your y-axis, it's your x-axis here, right? This is the edge of the board technically. So when it touches the x-axis, you're right at the edge. You're right at the where the board basically no longer exists past that point. Let's figure out the x-intercepts. Okay, so x-intercepts, let's figure them out. In this case, we only consider this one right here. I'll use a red pen for that one. There's only this one and this one that I need to worry about. There isn't another one anyways, but those two are the ones. So let's go ahead and find them. You let y2 equal to 0, and you hit graph. You should see that, right? And I feel like you might get an issue here. You might run into a problem here with it not finding it. Second trace intersect. Let's find that first intersection here. Enter, enter, enter. Oh, it did find it. So it's 11.62. Let me just see if there's another one on the other side. So I'm going to zoom in here. Zoom in. I'm going to go to that point where it touches. I'm going to zoom in again. Oh, look at that. It does cross it once here and once there. So I need to find this other one here. So second trace 5. I'm going to go closer to this one. Enter, enter, enter. That's 10.81. This one I had to zoom in for this one. And let's find the one way out there. So what should I do here? I'm going to go zoom stat back to the points that I originally had. I'm going to increase my X max a little bit. And let's go ahead and find this x-intercept here. Second trace 5. Go closer to that one. Enter, enter, enter. 44.99. So at a horizontal displacement of 1162, 1081, and 4499, it touches the edge of the board. Let's keep going. .37. State the y-intercept. What does this represent? In this case, the y-intercept is 0.5. It tells us that the arm starts at a vertical displacement of 5 centimeters try to just make it, tailor it to the situation. Tailor it to the situation. So at the very beginning, right, we're at 0.5 here. So the arm has a vertical displacement of 5 at the very beginning when this whole thing starts. Graph this scenario. I'll tell you this. When you have a table, you may use the table to graph. So you don't have to use the calculator and find additional points. You can just use the table that was provided to you. So, for example, I'm just going to see 0, 5, 10. So we had 0, 5, 10. I can use my calculator to help me out. 0, 5, 10, 20, 30, 35, 40. And then you had 5, 1.36, 0.04, 5, and 3.66. So you can use this, okay? You may use table if provided. So sometimes the province has simply given you a bunch of points and they're like, hey, sketch this thing. In that case, you can feel free to just use this to help you out. I found a bunch of points that will help me find, right, to make this a lot more accurate. So I'm going to base it on those points. So this would be horizontal in centimeters. And this is vertical, also in centimeters. And I know that the very last x-intercept, like the one that's way out here is, let me just go check here real quick, 44.99, okay? So if I make this 10, 20, 30, 40, 50, that works pretty good for me. $44.99 is basically 45, right? Like it's basically right here. So I'll plot that down. Then there's 10.8 and 1162. 10.8 is right about there. This would be 12, 14, 16, 12 and a half, 15 is right here. It's 12 and a half. So I need to move this over just a little bit. There and there. They're very close together, those two. And then 0.5. 5 is the highest this gets. So I'm going to go 1, 2, 3, 4, 5. One more, 6. So 5.5 is the highest I get. But I do start at 5, so that's my y-intercept. And then what's the other max? The other max happens at, let me just check here, 33.73.505. 33.70, so this is 35, 33 is right here. So I'm going to go up 33 and plot it just above 5 right there. And then you just graph it. And please don't put any arrowheads because we're just sticking to positives here. I'm just gonna say this didn't turn out as planned because technically this one goes past just a little bit, just dips under the x-axis here, which I didn't really want that to happen. So I'm gonna have to change that in this case. And then don't forget your equation. equation is y is equal to, I'm just going to rerun it here, negative 0.0008, I believe. 3 zeros and an 8, yeah. X cubed plus 0.06 x squared minus x plus 5. There you have your complete graph. Okay. State the restrictions on the domain and range. For your domain, you go from 0, right? You start at 0 for your x values all the way to this x-intercept here, which is 44.99. Okay, so that's your domain. If you choose to do set notation, that's absolutely fine. In this case, we're just going to call it x and y. That's your domain. For the range, it's a bit controversial here. The range is a little bit controversial because we do dip below just a little bit here. So technically we need to include that negative value here. I think for today we're just going to ignore that fact because I meant for it to land right on the x-intercept and then go back up. Because otherwise if you cut past the edge, you're actually not making this work, right? So we're just going to go from 0 all the way to the maximum vertical displacement, which is 5.05, or is it 5.5? 05, right? Yeah, 5.05. Or 0. There we go. There you have it. Write an equation that would result in the arm being taller. Arm being taller. Again, I want you to understand this. This one right here shifts vertically. Right? You changing that last value will either raise the whole thing or lower the entire equation, right? Or our armchair here that we're making. So if it's supposed to be taller, we're going to increase D. Increase D to make taller. Sorry, I'm running out of room. That's why I'm just writing that way. Negative 0.0008 x cubed plus 0.06 x squared minus x, and here I'm just going to go plus 6. Anything that's greater than the 5 that I originally had. This is the OG here. Look at how I did that, eh? Just a perfect transition to put OG into my lesson here. 0.008 x cubed plus 0.06 x squared minus x plus 5. This is the original equation here. I'm going to highlight that 5. Okay, that used to be 5. Now I changed it to 6. So I raised the whole thing to make it taller. That's your best bet. You can try to change the other ones as well. But this one, in my opinion, is the easiest one to adjust, and it'll make it happen. Okay. All right. Let's do a different one on 38. I'm going to ask you to enter those points and already figure out the equation. the bridge question. Let's try this question here. Always take an extra second, extra 15 seconds, and double check if you entered everything correctly. Because that is probably the most painful part about the whole process, is to get the initial equation wrong. It doesn't take long, and it can make all the difference, okay? As part of your work, tell me that you're typing the first row into L1, the second row into L2.
Good morning, everyone.
Okay, thank you, guys. Some exceptions, it went well. All right, I'll address that. We entered this into L1 and L2. We're going to look at the regression here. So the best way to do it is, I'll repeat this again. Plot 1 is only on if we're doing a regression. If you have that on and you're entering manually, sometimes it complains. It will actually not let you graph whatever you're trying to graph. So your first thing should be is like, oh, plot 1 is on, turn it off, right? That is a big reminder. So we're gonna go zoom stat, and we can clearly tell this is a quadratic, right? This is a quadratic here. So we would just say this, a quadratic would be best. Quadratic regression would be best suited since the scatter plot shows one turn. Okay? I'll repeat this here one more time. If you look at the scatter plot and there's any indication that this actually keeps turning, like it actually, one extra point that shows you, oh, wait a minute, this doesn't just keep going up, like there's one over here. Now you can't say it's quadratic anymore because, right, we're assuming there's going to be another turn there. So you just got to watch out and be careful what assumptions you're making. Determine the equation of best fit, write the equation, and let's do that. Stat, calc, quadratic regression, second 1, comma, second 2, comma, alpha, trace, 1. And that is our quadratic equation. So we just go stat, calc, followed by, in this case, it's a quadratic regression. So that's the bare minimum in terms of your keystrokes, right? Tell me, is it quadratic? Is it linear? Is it cubic, right? And then we write down the equation. 0.004 x squared minus 0.38 x plus 12.16 if you round it to 2 decimals. That is the quadratic equation that best fits. And we're just going to hit graph to see the results, and it works great. Everything is where it's supposed to. We're pretty confident this is right. You go ahead. What is the lowest height the cable reaches? At what distance from its first support does this occur? Okay, so we have these two pillars and the cable that goes like this. The lowest height is found here at the vertex. So let's go ahead and find that. Second trace minimum. We're going to go to the left of the vertex. We're going to go to the right. Enter, enter. And there it is. So I'm going to write down the coordinates of the entire vertex there. 54.04, 1.87. That is the actual coordinate of the vertex. So the lowest height is 1.87, and we are in meters. And because it's positive, this would be above ground, right? So if we ever have a negative height, we're talking below ground. At a distance of 54.04 meters from the first support. There you go. So the vertex gave us the answer to both of these pieces here. Both support structures are 10 meters above the bridge surface. Calculate the horizontal distance between. How would you find that? So let's do this again. You done? Okay. Just prop it open. So basically what they're saying is the height of these posts is at a 10-meter mark. Okay? And we want to find out what is the distance from here all the way to there. That's what we're trying to figure out. So I guess, I don't know if you remember, we did questions last year. It's like how long did the object spend, at or above a certain height. In this case, we're interested in these two instances, these two x values here that will give us the distance in between the posts. So this is y2 is equal to 10. Second, trace intersect. Let's call this P1, and this is P2, like post 1 and post 2 distance. So here we go. Y2 is equal to 10. Hit graph. And we've got a problem. It doesn't show up, does it? That's because every time you do a zoom stat, you will have to make some changes to your window. So let's go to our window. X min, I want it to be a little bit into the negatives every time. Y min, I also want that to be a little bit into the negative. So X min, Y min, I'm going to change that. Hit graph. So now you see your x-axis and you see your y-axis. I need to increase the y max on this a little bit as well. And it should be more than 10 because I'm going to graph the line y equals 10. So I'll make that 20. Y max is 20. Hit graph. And I start seeing the line. And I now realize that I need to increase my X max as well. So I'm going to go to Window. I'm going to change my X max to, let's say, 120. Whatever works for you. Okay. Now I have a better picture of what's happening. This is like within the context here. So let's find that first intersection. Second, trace 5. I'm going to find that one. Enter, enter, enter. That's 6.003. 26, sorry. We use 4 decimals when because we're going to have to subtract these two. Let me just bring that up a little bit for those of you in the back. So the first post, right, is 6 point something meters from the very edge of this. Let's say we're trying to connect to shores, right? So the first post is at 6.0026 from the shore. This post, let's find it. There we go. Enter, enter, enter. That's 102.0690. So you got half a mark, and then this next step is another full mark for this one. Delta P is where you just subtract those two numbers. If you want full marks, I would suggest you round to 4 decimals when you retrieve the points, subtract them, and then round to 2 decimals at the very end. So this is 96.07 meters between supports. So you're almost guaranteed you're gonna have to use second trace value, or let y be something and figure out intersections. If it had just said how far from the shore is the first post, you would say 6.00 meters, right? How far from the shore is the second post? It's 102. But if you want the distance between them, you need to subtract that to figure out that distance, all right? And if you wanted to sketch this, let's go ahead and do that. So today I'm just talking a lot. I apologize. Too bad you can't go ×2, right, Jed? A little faster. Height m. This would be distance in meters. All of that is given to me by the question. I just figured out the two posts, right? It says graph the stretch of the curve between the support structures, right? This is the posts. So I know that the first one is about at a distance of 6, and the other one is at a distance of 106 or something, right? 6 and 102, I should say. So let's see what works here. I'm going to try 25, 50, 75, 100, 125. That works pretty good. So I'm going to go up. What if I did 20s? Let's try this. 20, 40, 60, 80, 100. That would work as well. So how about, I'm going to go with 20s. Sorry about that. If you go with 25, there's nothing wrong with that. I think for me, it's just a bit easier to graph going up by 20s than 25. That's just my preference. And then going up or down, I need to make sure the posts are 10 meters high, right? So 2, 4, 6, 8, 10, 12, right? So clearly indicate where the numbers go. So that's a pretty good, that will encompass everything I need here. So 6, 10 basically. So this is 10 here, 6 would be right about there. So I'm going to go all the way up to 10. Close enough is good enough. The other one is at 102 point something. 102.06, so 100. 102 is right about there. You plot that at the 10 mark line. The vertex was 5404, 1.87. This is 50. 54 is right about there. This would be 1 right here, 1.5, 1.87 is right about there. Close enough is good enough. And then you just graph it like that. Don't forget your equation. For the domain and range, it goes below there, but I'm going to do that right here. For domain, if all we care about is the stretch between the posts, we go from 6.00, technically, all the way to 102.07. And I will make a note here. This is post 1, and this is post 2. For the range, the lowest I ever get to is 1.87, right? That's the lowest part of the curve, and the highest is 10. So that is how you would figure out your domain and range, looking at the scenario here. And notice that I'm going to highlight domain and range is basically, we call that a restriction. We're restricting it to this scenario because guess what? Our calculator actually could graph this like going into negatives, right, into the thousands, right? Either way, but we're restricting it to just this part right here. That's why our domain and range is there. Next here. G, due to climate change, engineers would like to model a bridge that will be higher off the ground. Okay, you want a bridge that's higher off the ground. Write an equation that would represent such change. Literally, you make up your equation, whatever you like. Okay, so I will say increase the constant C in this case, because C is always going to represent a vertical change. So example would be y is equal to 0.0035 x squared. So I'm keeping everything else the same. Go ahead. I'm just going to make this, what should this be? Plus, I'm going to use a different color for this. I'm going to go plus 20, let's say. I don't know. Water could rise significantly, so why don't we just, instead of just going up by a little bit, we go plus 20, okay? Because that would actually result in a curve that's higher. So if you wanted, what is happening is if this is the original, the new one would be like this, okay? It raises everything up. If you change C, it raises everything up. If you increase it, if you decrease it, it would actually do the opposite. You would lower that bridge. You would lower the curve. State the new domain based on G. How would you do this one? This one is actually tougher than what it looks. But all of a sudden, we know that the posts are still at 10, right? This is still 10. But now you have that new equation here, the plus 20. So let's go ahead and just type in, go to your equation on y1, and I'm going to do a shortcut. I'm just going to go to the very back of it. And instead of the plus 12, I'm just going to go plus 20.000, so I don't have to delete anything. Hit graph. There it is, no surprises. And I need to find the distances here. So I'm going to go second trace 5. Enter, enter, enter. This one is 45.05. And this one over here is 6302. That's within this scenario. Obviously, they would probably raise the posts. They would make them taller as well. But we're assuming just the curve is being, just the cable is being raised. So my domain would be 45.05 to 63.02. And the range I know our brains are thinking lunch already. But what do you think the range would be if we raise the entire thing by 10 units? Could we just use our previous range and make that, just use that? Yeah, we could use our previous range. So let's go, what was it before? It used to be 1.87, right? That's the lowest point. How much did we raise the whole thing by? It's actually trickier than, it used to be 12.16. Now it's 20. So it's going to be, we got to add, let me see here, 20 minus 12.16. I'm too nervous to do the mental math on this one. I know I'm going to mess up. Higher. Highlight that part. Oh, you can't see that. Sorry, guys. There. 20 minus 12.16. That's what it used to be. It means that the new cable, the supporting cable, is 7.84 meters higher. Okay? So I'm going to go 1.87 plus 7.84 to give me my starting range. And I'm going to go 10 plus 7.84 for this one. Okay? So this is 17.84. And this one is 9.71. Okay, so that's my new range compared to the last one. Okay, I'm going to stop talking, otherwise I do want to get you started with 40 and 41. Just to some nuances here. Let's go to 40. The 1 hour record is the farthest distance traveled by a bicycle in 1 hour. The table below shows the world record distances and the dates that they were accomplished in. Notice this, you do have a horizontal table where this is L1 and this is L2. So you're going to have to watch out a little bit here. If you enter 1996, right, that's the year 1996, your value is going to be way down the x-axis, right, like at 1996. So you can either choose to enter the actual values here, okay, or you can say this is 0, 1, 2, 3, 4, 5, 6, and so forth. I would say I prefer you entering the actual year. Don't go 0, 1, 2, 3. Okay? Because actually, I made a mistake now that I think about it. If 1996 is year 0 for us, what would 1998 have to be? That's like 2 years later, right? Compared to 1996. So this would be 0, this would be 2, this would be 3. 2004 compared to 1996 is 6. So it makes it complicated if you do that. I'm going to erase the other ones. Okay? So some students like to do that. I would not. I would say use the actual dates, the actual years. That's way better than the other way around. Okay, so I'm going to ask you to try that one. So basically page 40, page 41, page 42, and 44. 44, folks, is a graph. I will just tell you this. Find, on page 44, find 4 points. Remember, a quadratic needs how many points to come up with a regression? Needs 3. A cubic needs 4. A linear, which is a degree of 1, needs 2, right? So that is the minimum. When you get to 43, I don't expect you, but that one I want to explain to you tomorrow how to do the box, like a volume. Volume is a cubic. I want to explain that one. So if you want to give it a try, go for it. But I'm just going to expect you to do everything up to 44, okay? So page 40 to 44 is your homework. I would say if you don't want a graph, I'm okay with that, but come up with the equation and try to answer the questions that are there. If you want to skip the graphing at this point, I'm okay with that because most of the regression type scenarios are not going to include a graph on the provincial exam, okay? So that's it for today, guys.